We are going to work through this handout on operations of functions. The handout's posted in Canvas. And what we get to a little later on in the handout is incredibly important. All right. So it starts out a little bit on the light side, but it gets very, very important later on. So let's just get started with these first couple of exercises. We can add, subtract, multiply, and divide functions. This is usually very straightforward, and let's go ahead and do exercise 1 that I have rewritten here on a sheet. Let f of x equals x squared plus 4 and g of x equals 1 over x. We want to find f plus g and f times g. So f plus g of x just means add f of x plus g of x. So there's nothing terribly profound here. We take x squared plus 4 and add 1 over x. I'm pretty much happy with this version, but it's true you can combine these if you'd like into a single. You can combine the terms into a single fraction, and you should know how to do this. If you take x squared, which is x squared over 1, to get a common denominator of x, we would want to multiply by x over x. The 4 term, which is 4 over 1, we'd also want to multiply by x over x. And the 1 over x we would just leave alone. So we end up with x cubed over x plus 4x over x plus 1 over x. And so this answer can be expressed as x cubed plus 4x plus 1 all over x. Okay. So these two versions of the answer, these are equivalent. And I would be okay with either one of those. There's f plus x. We also want to compute f plus g. We also want to compute f times g of x, which just means to take f of x times g of x, multiply the two functions together. So we're going to take x squared plus 4 times 1 over x. I want to write x squared plus 4 in parentheses so that I get the grouping correct here, or the order of operations correct. And since I have a fraction, I can write x squared plus 4 over 1 times 1 over x and just multiply across. I get x squared plus 4 over x, and there's my product. There's exercise 1. Now exercise 2 is a little bit more intense, and I have that rewritten here too. I'm going to call this optional because this really goes beyond what we got to know. So you can skip this if you'd like, but if you want a little bit of a challenge, you can think about it and maybe try it before you watch the rest of this video. So what if we have a piecewise function, f of x defined in 2 pieces, as written here, and g of x also defined in 2 pieces? What would it mean to add those functions together? You know, like how you calculate f plus g depends on where x is. If x is a number like 1, say x equals 1, for f, you would have to use the lower part of the formula because 1 is greater than or equal to 0. And for g, let's see, for 1, you would have to use the upper part of the formula because 1 is greater than negative 2. So for different numbers, sometimes you use the first or second part of the f formula, and sometimes you use the first or second part of the g, but you can kind of flip-flop around, right? So we need a way to sort this out, and there's a lot of ways you could approach this. And what I'm going to do is, where's my red pen here? I'm just going to try to turn this into a schematic. So don't worry about learning some sort of special technique for solving these. Just think of this one way in which I'm approaching this problem, and take it or leave it. Don't worry if you don't get it. So, 0 is kind of the dividing point here for f, -2 for g. So on an x-axis number line, I'm going to mark -2 and 0. So I'm thinking of that as a copy of the x-axis. And then let's see, above, I guess I'm gonna describe the function f above. So if x is less than 0, and the way I'm going to represent that is draw an open circle above the 0 and draw a line extending to the left. It's kind of like a number line graph, right? That's when I use the x minus 1 formula. But if x is greater than or equal to 0, so I'm coloring a circle here and shading to the right, that's when I use the -x plus 2 part of the formula. That's for f. Now what about for g? For g, if x is greater than -2, I use the x squared expression. But if x is less than or equal to -2, I use just the constant -1. So I hope, that's an x minus 1 here. I hope you can see that things kind of get divided at -2 and at 0, right? And for, I'm going to draw a line and then write f plus g. What can I say? Well, if I'm greater than or equal to 0, I use the -x plus 2 formula for f and the x squared formula for g. So greater than or equal to 0 for f plus g, I'm going to use -x plus 2 plus x squared. If I'm less than or equal to -2, I'm going to use the x minus 1 formula for f and the -1 for g. So when I add those together, I got x minus 1 minus 1 plus another -1. And then when I'm in between -2 and 0, not including -2, not including 0, when I add these functions together, I would add the x minus 1 and the x squared. And so that is really telling me how to describe this f plus g of x function. It's going to be in 3 pieces. There's going to be one piece if, for this piece here, if x is less than or equal to -2, I'm going to write x minus 1 minus 1, that's x minus 2. If x is between -2 and 1, so -2 less than x, between -2 and 0, sorry, -2 less than x less than 0, then I'm going to use, I'll rewrite these terms in order, x squared plus x minus 1 for the sum. But if x is over here, meaning greater than or equal to 0, then the expression I use for the sum is x squared minus x plus 2. So it turns out I need 3 pieces to describe the sum of the 2 functions f and g in exercise 2. So here's my answer to exercise 2. And again, just if it doesn't make sense, don't worry about it. That's something we're not going to really dwell on further.